Hello guys, so in this video I want to discuss equation of the lines. So the problem is that we all remember equation of y equals mx plus b from the high school, middle school, like college. And this equation describes exactly a line in 2D. And what does it mean? It means that the slope of this line is going to be m, and that our line has b intersection with y-axis. So this point has coordinate 0, b. But the problem is, because multivariable calculus talks about more than like two-dimensional space, it's talk about three-dimensional space. And in three-dimensional space, we also can have a line. So how are we going to describe the line? Because we can see that in a plane, another form how we can write our line is going to be ax plus by equals to c. So we can get our equation y equals mx plus b by moving ax to the right hand side, so we'll have by equals to c minus ax, and by dividing both sides by b. So m is going to be negative a over b, and our b is c over b. Yeah, it's silly. So, but the problem is, how I'm going to write this equation in 3D? Is it going to be ax plus by plus cz equals to d, or what? No, this is actually going to be equation of the plane that I'm going to discuss in my next video. So if we want to write equation of the line in 3D, we need to reconsider how we thinking about this line. What pieces of information do we need for this line? So let's take some example. Let's take example y equals minus x plus 1. And here I'm going to show how we can, from this example, derive parametric equation of the line, vector equation of the line, and symmetric equation of the line. By deriving these all three equations for line in 2D, we can do the same in 3D. Okay, so first thing, let's graph our line. I can see when x equals to 0, I will have 1. When y equals to 0, I will have when y equals to 0, x is 1. When x equals to 0, y is 1. So I have these 2 points, so this is my line. So the trick is to take this equation, which you can see clearly is in Cartesian form, and write this equation into parametric form. So as you remember, I can write this equation as a parametric form to telling let's x to be equals to t. Then if x is t, we can see that y equals to 1 minus t. Yes, and this is going to be exactly the equation, parametric equation of the line. So first, let's discuss when t equals to 0, what is my point? When t equals to 0, my point is going to be exactly x is 0, y is 1. Okay, but what about when t equals to 1? When t equals to 1, I have x is 1 and y is 0. So I have this point. So according to parametric equations, I know that my direction on the line goes this direction. So it means if my point starts like my particle t equals 0 at this point, when my time increases, it goes over here. And small remark, so the general form for parametric equation of the line in 2D are the following. X equals a1 plus b1t, and y equals a2 plus b2t. Okay, so we derive parametric form, and let's discuss vector form, or in other words, vector equation. For the vector equation, we know that if we have some vector, let's say r, then our vector r has two components, x and y. But we know that my x is t and my y is y minus t, so I can replace x with t and y with y minus t. And here I can think about my first component. You can see that constant term is missing, so I can write this as 0 plus t and 1 minus t. But according to vector addition, I can split this sum, sum subtraction, into two vectors. The first vector with numbers 0, 1, and the second vector with component t. So I will have just t and t. But here we're using another property of my vector, that if I'm multiplying vector by the same constant, I can factor this constant out. So I will have 1, 1 times t. So what I got that my, let's say, r of t, and why I have r of t, because I can see that this left-hand side formula equals to the right-hand side, which depends on t. Then r of t is equals 0, 1 plus 1, 1t. And this is exactly the vector equation of the line. So let's discuss what does it mean like that we have this vector equation. And the best thing is to understand this vector equation is just try to plug in different values of t and see what I'm going to get. So since I have this vector equation as r of t is 0, 1 plus 1, 1t, then you can see that on the left hand side you have a function in terms of t, and on the right hand side you have vectors. So for different value of t, your output is going to be a vector. So let's plug in different t and see what vectors I'm going to get. So if t equals to 0, then my r of 0 is going to be just a vector 0, 1. When t equals to 1, then r of 1, I can see that I will have, here I have a typo. And my typo is that I have minus t. So I have minus 1 here, minus 1 here, and minus 1 here. Yeah, sorry about this. Yeah, I did this mistake is right here. Okay, so then r of 1 is going to be 1, 0 plus 1 is 1, my first component, and my second component is going to be 0. Okay, what about when t equals to, I don't know, like, to say like 1/2. And t when equals to 1/2, I will get that my first component is going to be 1/2, and my second component is going to be 1 minus 1/2 is going to be also 1/2. So let's plot these vectors. When t equals 0, I have vector 0, 1, and 0, 1 is exactly this vector. So this vector is r1, r of 0. When t equals 1, I will have the vector 1, 0. So I will have this vector r of 1. And when r equals 1/2, sorry, when t equals 1/2, I will get the vector r 1/2, 1/2. So I will get something like this. So I have all 3 points. And for all these 3 points, I can draw a line through these 3 points. So I get the same line. So idea of a parametric equation that you describing any point on a line by drawing a vector to this point. So in some sense, you taking a vector and you just tracing this vector to like in the direction of your line. And you can describe the movement of this vector by having written your equation of the line in vector form. So my equation of the line is written r of t equals 0, 1 plus 1 minus 1 t. So you can see that we have 2 vectors, vector with constants, just numbers, and vectors that multiply by t. So let's name this vector p, and let's name this vector d. P stands for positional, and D stands for directional. And then my equation of the line, r of t, can be rewritten in terms of p and d. So I will have p plus d times t. And this is my final equation, how it looks like in vector form. The equation of the line in vector form. But let's see the meaning of p and d in our example. Okay, so my p equals to 0, 1, and this is going to be exactly this vector. And the reason why it's called positional, because you can see it tells me through which point my line goes. So in this case, my line goes through the point 0, 1. But what about directional vector? Directional vector, you can see in this case, has coordinates 1 and minus 1. And directional, like, it says the direction of the line, and you can see exactly the direction, the slope of my line. So d in other words is the slope, is I go 1 in x direction, and then I go negative 1 in y direction. So this is going to be exactly my vector d. So the equation of the line is p equals dt. It makes sense. Why? Because when t equals to 0, I have just vector p. So I'm gonna get this point on the line. When t equals to 1, I will have my vector p plus vector d. And by the rule how we're adding vectors, we're gonna get exactly this vector, which in our case was like r of 1. So we can see that if we're gonna take our vector d and stretch vector our d further, or like we're gonna make it shorter, or even we're gonna reflect the direction and go like in opposite direction. So multiplying our vector d by some constant t, we're making our d smaller or bigger. So in this way, we always can reach any point on our line by making t sufficiently large or small, or with like negative values. Okay guys, thank you for watching. In this video I introduced the idea of writing vectors in parametric form, or parametric equation, vector equation. Oh, I haven't discussed symmetric equation, so I'm gonna discuss symmetric equation in my next video, and I'm gonna show you how you can write equation of the lines in 3D. Okay, thank you for watching. Bye bye.